One of history's deadliest dam disasters began with a dam that survived. On the night of October 9, 1963, the Vajont Dam in northern Italy stood nearly 262 meters high across a narrow alpine gorge. It was a thin, concrete arch built to hold a hydroelectric reservoir. But the structure itself was not what failed. Across the water, the northern slope of Mount Toc broke loose. Roughly 270 million cubic meters of rock and debris plunged into the reservoir in only a few tens of seconds. The impact displaced an enormous volume of water, sending a wave over the dam and into the Piave Valley. Longarone and nearby communities were devastated. Italy's civil protection records 1,917 deaths. The paradox was immediate. One of Europe's worst reservoir disasters left the dam largely standing. To understand how, the story has to move backward to the warning signs that appeared before the reservoir was fully used. The dam was built as the centerpiece of a larger hydroelectric system. Its narrow canyon was ideal for a tall arch, but the surrounding slopes were the real uncertainty. In 1959, a landslide at the nearby Pontese Reservoir generated a damaging wave, showing what a collapsing mountainside could do to stored water. The first filling of Vajont began in February 1960. Soon, rockfalls and ground movement appeared on Mount Toc. Geologist Edoardo Semenza, working with Franco Giudici, interpreted evidence on the slope as a huge ancient landslide. By late October, a crack roughly 2 kilometers long traced the outline of the future failure. Then, on November 4th, about 700,000 cubic meters of rock slid into the lake. It was small compared with what would come, but it proved the mountain was active. The reservoir was lowered. Instruments monitored the creep, and a bypass tunnel was built so water could still pass if another slide blocked the basin. Engineers also commissioned a physical hydraulic model. The danger was no longer hypothetical. The question had become how large and how fast the final movement might be. Between 1961 and 1962, tests were run on a 1:200 scale model of the reservoir. Different slide shapes, volumes, and water levels were used to estimate the waves a future collapse might create. Those experiments helped support the idea that a reservoir level around 700 meters above sea level could be managed without a catastrophic downstream wave. But later studies note that the tests never reproduced the sudden, simultaneous failure of the entire rock mass. Meanwhile, Mount Toc kept moving. Changes in movement during filling, rainfall, and drawdown encouraged the belief that water level could help manage the hazard. Modern geological research still debates the exact trigger and failure surface, but water and groundwater conditions remain central to many interpretations. In 1963, the reservoir was raised again, and the slope accelerated. By late September, operators were lowering the water toward the level they believed safer, yet the mountain kept moving faster. The strategy depended not simply on predicting a landslide, but on the landslide behaving within assumptions about speed and scale. Once the final acceleration began, lowering the lake could not make the mountain wait. On October 9th, the monitored slope was moving at an alarming rate. At 10:39 that night, the northern flank of Mount Toc collapsed. about 270 million cubic meters of rock and debris rushed into the reservoir at speeds estimated around 20 to 30 meters per second, filling much of the basin in only a few tens of seconds. Water surged in several directions, climbed the opposite slopes, and swept over the dam. The reservoir did not need to burst open. The landslide had already converted stored water into a fast-moving flood. Minutes later, the wave raced through the gorge and struck Longarone. Buildings were swept away so completely that aftermath photographs show broad fields of debris where streets had been. Communities around Urto and Casso were also hit. The dam's concrete arch remained largely intact, leaving one of the most unsettling engineering images of the 20th century. A standing dam above a devastated valley. Criminal proceedings from 1963 to 1971 assembled technical reports, testimony, seismic records, models, and photographs. UNESCO now preserves that archive in its Memory of the World Register as documentation of human responsibility in the tragedy. Geologists still study Vajont because parts of the failure mechanism remain debated, but one fact is not. A known moving mass stood beside a reservoir, and the final slide exceeded the assumptions used to manage it. Today, both the scar on Mount Toc and the dam remain visible. Vajont endures because the structure survived long enough to show exactly where the catastrophe did not begin.